Question: how many are, you write down like this. Question: A triple B is a perfect square. A triple B is a perfect square. A and B are digits. Find the value of A plus B. A triple B, it is a perfect square. Step number 1. A perfect square never ends with 2, 3, 7 or 8. It is out. It cannot end with 0 here because it will become 1,000 or 2,000 or 3,000. A perfect square always ends with even number of zeros. It cannot end with 1 because any perfect square ending with 1, tens place should be an even number. Should be an even number. It cannot end with 5. Why? Because any perfect square ending with 5, tens place is 2. 15 square 225. It cannot end with 6. Why? Because 4 square 16, 6 square 36. If the unit digit is 6, tens place will be odd. It cannot end with 9. Why? Because 7 square is 49, 13 square is 169. If the units place is 9, tens place will be even. Only one case that is possible, it is 4. So here also it will be 4. Here also it will be 4. So we have to find the number which is of the form A444. So take the last 2 digits 44. What is the concept? X square 50 plus or minus x whole square, 100 plus or minus x whole square has the same last 2 digits. X square 50 plus or minus x whole square, 100 plus or minus x whole square has same last 2 digits. What is the smallest number on square? I will have 44. 12 square is 144. 50 minus 12. 50 plus 12. 100 minus 12 is 88. So 38 square is nothing but 1,444, which will satisfy the condition. 38 square is 1,444. A plus B value is 5. I hope this is clear. A triple B is a perfect square. A perfect square cannot end with 2, 3, 7 or 8. It cannot end with zeros because there will be 3 odd number of zeros. It cannot end with 1. A perfect square ending with 1, tens place is even. Any perfect square ending with 5, tens place is 2. A perfect square ending with 6, tens place is odd. Any perfect square ending with 9, tens place is even. All these cases are not possible. With a few examples you will come to know. So the only case possible is 4. 4, 4, 4. Right? What is the smallest 2-digit number on square? I will get 44. 12 square is 144. X square 50 plus or minus x whole square, 100 plus or minus x whole square. 12 square is 144. 50 minus 12, 50 plus 12. 100 minus 12. So what is the smallest? Right, 2-digit number on square? I will have these A triple B, 1,444. A plus B equivalent to 5. I hope this question is clear. Second question. Conceptual clarity building with problems. CD, C or you write down like this. AABB is a perfect square. AABB is a perfect square. Find the value of A plus B. AABB is a perfect square. Just now we have seen the only number which will have last 2 digits same is 44. AA 44 is a perfect square. AA 44 is a perfect square. Method 1. What is the smallest number on square? I will get 44 at the end. 12 square is 144. 50 minus 12. 50 plus 12, 100 minus 12. This is 7744. This 3844. 38 square is 1,444. AABB. So answer for this question is 7 plus 4 equivalent to 11. 7 plus 4 equivalent to 11. 11 is the answer. Method 2. Method 2. Listen carefully, sir, here. AA44. AA44 is a perfect square. AA44 should be divisible by 11. Why? Because sum of the odd places minus sum of the even places, sum of the odd places minus sum of the even places should be divisible by 11. Why it is 4? From the previous question. 4 plus a, 4 plus a, it is divisible by 11. So it is divisible by 11. So what is the number that is divisible by 11 and ending with 44? 12 square is 144. 50 minus 12. 50 plus 12. 100 minus 12. Which number is divisible by 11 out of these three numbers? Not possible, not possible. The only number possible is 88 square. 88 square is 7744. So answer is 7 plus 4 equivalent to 11. 7 plus 4 equivalent to 11. I hope why it is clear, right? Because it is a perfect square. It cannot end with 2, 3, 7 or 8. It is 0 not possible, 1 not possible, 5 not possible, 6 not possible, 9 not possible. The only possibility is 4. AA44 is divisible by 11. So 4 plus a minus of 4 plus a, it should be divisible by 11. So out of 4 numbers, the lowest number is 12 square 144. Which number is divisible by 11? 88 is divisible by 11. Second problem, is it clear? Third one. At the beginning of the session 1, we told that we will discuss few questions. ABCD is a perfect square. ABCD is a perfect square such that AB is a prime number, and CD is a prime number. CD is a prime number. How many numbers, how many values ABCD can take? Another variety. How many 4-digit perfect squares are there where the first 2 digits is a prime number and the next 2 digits is also a prime number, and it is a perfect square? Because it is a perfect square, D cannot take 2, 3, 7 or 8. D cannot take 2, 3, 7 or 8. And it is said that CD is a 2-digit prime number. If CD is a 2-digit prime number, CD has to be an odd number. CD has to be an odd number. So because any prime number other than 2, it is an odd number. So D cannot take, 0 cannot take, 4 cannot take, 6 cannot take, and what is the case? 5 also it cannot take. Because if D is 5, then the number is divisible by. And now, if D is 5, you can ask a doubt. Sir, 0, 5 is a prime number. But beta, ABCD is a perfect square. Any perfect square ending with 5, tens place is 2. 5 also it is not possible. 5 also it is not possible. I hope the idea is clear. When D equivalent to 1. If D equivalent to 1, ABCD, CD is a perfect square. C1 is a perfect square. If C1 is a perfect square, 0, 1, 1 square 1, 9 square 81, right? That's all. 2 cases are only possible, right? 0, 1, 81. What are all the prime? 0, 1, 31, 21, 41, 51, 61, 71, 81, 91. These are all the cases of a 2-digit number. But CD should be a perfect square. CD should be a perfect square. These are not possible. These are not possible. 0, 1 and 81. 1 is not a prime number. 81 is also not a prime number. D equivalent to 1 also out. When D equivalent to 9. When D equivalent to 9, that means C9 should be a perfect square. If C9 is a perfect square, what are all the cases that is possible? Write C9, or C9 we will take first, it is a prime number. First it is a prime number. I hope it is clear, right? Or if you want me to solve it, I will do. I think I am going little fast, so I will reduce. I will do one by one. One by one we will solve it. I hope till here it is clear, right? Till here. So what are the cases possible? D is 1. Again see here, sir. Case 1. D equivalent to 1. If D equivalent to 1, C can range from 0, 1, 11, 21, 31, 41, 51, 61, 71, 81, 91. Listen carefully. What is that question? ABCD is a perfect square. Any perfect square ending with 1. Tens place should be an even number. Tens place should be an even number. Tens place should be an even number. These are all the cases. 0, 1, 21, 61, 81. Now CD is a prime number. 81 is not a prime number. 21 is not a prime number. 1 is not a prime number. I hope it is clear, right? So what is the case that we got? 61. What is the smallest number? 19 square is 361. 50 minus 19. 31 square is 961. 100 minus 19. 81 square, which is 6561. 50 plus 19, 69 square, which is 4761. 4761. 47 is a prime number. 61 is also a prime number. So I got a case in D equivalent to 1. What is that case we got? 47, 61 we got. Again I am telling you, when D equivalent to 1, D I kept to 1. C can be ranging from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. CD is a prime number. So 21 is not a prime number. 81 is not a prime number. 91 is not a prime number. So what is that case? 30, any perfect square ending with 1, tens place should be even. So only case that is possible is 61. I hope it is clear. 19 square is 361. 50 minus 19, 50 plus 19, 100 minus 19. 4761 we got. Now case number 2. Case number 2. Now I will do case number 2. You can do an analysis of case 1 after this. Again I am doing case 2 orally, sir. Case 2. Let me do it orally. What is case 2? ABCD is a perfect square. AB is a prime number. AB is a prime number. What is CD? CD is also a prime number. What is case number 2? When D equivalent to 9. If D equivalent to 9, what are all the possible cases? 9, 19, 29, 39, 49, 59, 69, 79 and 89. Condition is CD should be a prime number. 39 not possible. 49 not possible. Right? 69 not possible. ABCD is a perfect square. Any perfect square ending with 9. Any perfect square ending with 9. Tens place should be an even number. Any perfect square ending with 9. Tens place should be an even number. Tens place should be an even number. Two cases that I got. 29 and 89. 17 square is 289. Smallest number. 50 minus 17. 50 plus 17. 100 minus 17. 29. 23 square is 529. 50 minus 23. 50 plus 23. 100 minus 23. 33 square is 1089, 67 square is 4489, 83 square is 6889, 23 square is a 2-digit number. So 73 square is 5329, 77 square is 5929, 5929. So totally how many numbers which we got? So we got 69 square is 4761, 73 square is 5329, 77 square is 5929. Total if you see, ABCD is a perfect square. AB is a prime number and CD is a prime number. Totally 3 numbers are possible. A very, very good question which helps you to use the perfect square concepts, and also perfect square never ends with 2, 3, 7 or 8. If it is ending with some other number, how to solve? I hope the idea is clear. Kindly revisit this question again in the next 48 hours once the class is uploaded. Idea clear? Next, one more question. Quality questions we will discuss in our class. How many 4-digit perfect squares? Tens place 1. How many 4-digit perfect squares has tens place 1? ABCD is a 4-digit number. It is a perfect square. Tens place is odd. Already we discussed it. Tens place is odd. Tens place is odd only when D equivalent to 6. Already we discussed this. Only when D equivalent to 6, tens place will be odd. 4 square is 16, 6 square is 36, 14 square 196, 16 square 256. Only when the units place is 6, tens place will be odd. So units place is 6, tens place is 1. So this is nothing but 16. What is the smallest number on square? I will get 16. 4 square 16, 50 minus 4, 50 plus 4, 100 minus 4. This is nothing but 2116. This is nothing but 2916. This is nothing but 9216. How many numbers 4-digit perfect squares has a tens place 1? Answer is 3. Quality questions we will discuss. The entire idea in the question is tens place is 1. Tens place 1 is an odd number. 1 is an odd number. Tens place will be odd only when the unit digit is 6 and the number is a perfect square. And the number is a perfect square. 4 square is 16, 50 minus 4, 50 plus 4, 100 minus 4. One more question. When the tens place is even, we will see. How many 4-digit perfect squares? How many 4-digit perfect squares? Tens place 4. How many 4-digit perfect squares has a tens place 4? So AB 4D. It is a perfect square. AB 4D. It is a perfect square. A perfect square never ends with 2, 3, 7 or 8. These out. A perfect square cannot end with single 0. It is out. A perfect square ending with 5. Tens place will be 2. So 5 is out. So 3 cases. Case 1. When D is nothing but 1. D is AB 41. What is the smallest 2-digit number? On square I will get 41. 21 square. 50 minus 21. 50 plus 21. 100 minus 21. Case 1. Case 2. D value 1 over. Next is D value 4. AB 44. It is a perfect square. 12 square is 144. 50 plus 12. 50 minus 12. 100 minus 12. 3 numbers. I hope it is clear. Case number 3. When D equivalent to 9. AB 49. What is the smallest number? 7 square is 49. 50 minus 7. 50 plus 7. 100 minus 7. So total 3 numbers here. Total 3 numbers here. Total 2 numbers here. 29 square is 841. So you can check all the number. 93 square is 8649. 57 square is 3249. 43 square is 1849. 88 square is 7744. 38 square is 1444. 62 square is 3844. 69 square and 71 square. Similarly, you can solve it. I hope it is clear. 6241 and another is 5184. So both these 41 14, right? So 14 1. So I think it's 5041. Key point 1. We will do according to key points. What we did is understanding of the concepts. Key point 1. Squares of the numbers. Squares of the numbers ending with 5. Squares of the numbers ending with 5. Squares of the numbers ending with 5. In that one, type 1. Type 1. Multiple types we will discuss. Type 1. 15 into 15, which is 225. 25 into 25, which is 625. 15 into 25, which is 375. Very, very important concept. If it is ending with 5, 1 is an odd number. Again 1 is an odd number ending with 5. 2 is an even number ending with 5. 2 is an even number ending with 5. 1 is an odd number ending with 5. 2 is an even number ending with 5. In the first two cases, what are the last two digits? Last two digits is 25. When you multiply two odd numbers ending with 5 and two even numbers ending with 5, last two digits is 25, else it is 75. Please write down this concept. When you multiply any two odd numbers ending with 5 or any two even numbers ending with 5, last two digits will be 25, else the last two digits will be 75. Odd 5 into odd 5, 25. Even 5 into even 5, 25. Odd 5 into even 5, 75. This is a concept. This is the concept. Now, examples we will do. It should be extremely clear to you. Odd 5 into odd 5, 25. Even 5 into even 5, 25. Odd 5 into even 5, 75. Now, examples. First example. Find the last two digits for. Find the last two digits for 535 into 865 into 475 into 195 into 235. Find the last two digits for 535 into 865 into 475 into 195 into 235. Forget about these 5. Just determine the tens place nature. Tens place nature. 53 is an odd number or 3 is an odd number. 86 is an even number. 47 is an odd number. 99 is an odd number. 23, 3 is an odd number. I hope it is clear. Odd 5 into even 5, 75. Odd 5 into odd 5, 25 into odd 5. 2 is an odd number. 2 is an even number, 7 is an odd number. Odd 5 into odd 5, even 5. So 25 into 25, even and even. Last two digits is 25. Last two digits is 25. 5 omit it, that will do it little later. A number is said to be an odd number if the unit digit is an odd number. If the unit digit is an odd number. So 53, it is an odd number. 86, even number. 47, odd number. 19, odd number. 23, odd number. Odd 5 into even 5, 75. Odd 5 into odd 5, 25 into odd 5, 7 is odd, 2 is even. Odd 5 into odd 5, 25. 25 into 25. Answer is 25. First question. I hope it is clear. Second question. 1985 into 5215 into 3465 into 9375. Find the last two digits of these number. Find the last two digits for this number. Try to solve it, sir. 1985. 198. 8 is an even number. 555, omit it, sir. 555, omit it. 521, it is an odd number. 346, even number. Even 5 into odd 5, 75. Even 5 into odd 5, 75. Odd 5 into odd 5, last two digits is 25. Odd 5 into odd 5, last two digits is 25. I hope with second example, it should be extremely clear to you, sir. With second example, it should be clear to you. I hope it is clear. Next one. Third example. Shall we? Third example. 1345 power 120. 1345 power 120. Find the last two digits of this number. Find the last two digits of this number. Method 1. Method 1. This is nothing but 1345 power 120. So it is nothing but 1345 into 1345 and so on 120 times. 134, it is an even number. Even and so on 120 times. Even multiplied any number of times. It is 25. Method 1. Method 2. Power is an even number. If the power is an even number, then the number will become a perfect square. Then the number will become a perfect square. Then the number will become a perfect square. Any perfect square, 5 square 25, 15 square 225. Any perfect square ending with 5, last two digits is always 25. If the power is an even number, if the power is an even number, right, and the base is ending with 5, last two digits, right, 120 is an even number. If the power is an even number and the base is ending with 5, last two digits is always 25. Last two digits is always 25. Few more questions. 515 power 68. 895 power 43. 895. Power is an even number. If the power is an even number, then the last two digits is always 25. Last two digits is always 25. These are nothing but 895 power 42 into 895 power 1. These are nothing but 25. Why? Because the power is an even number into 895. 2 is an even number, 89 is an odd number. Last two digits is 75. Last two digits is 75. I hope any power odd number is there. You can easily solve by using these logic. 365 power 121. These are nothing but 365 power 120 into 365. Power 120 is nothing but power is an even number. Last two digits is 25. Into 365. 2 is an even number. 36 is also an even number. Even 5 into even 5. Last two digits is 25. I hope the logic is clear. Even 5 into even 5. Last two digits is 25. Odd 5 into odd 5. 25. Even 5 into odd 5. Last two digits is 75. In key point 1, type 1 we discussed. Type 2. So, we discussed A5 into B5, A5 into B5. If A and B both are even, last two digits is 25. When A and B both are odd, last two digits is 25. One is even, one is odd. A is even, B is odd, or A is odd, B is even. Last two digits is 75. The number before is given by A into B plus A plus B by 2. Here if you get any decimal, please ignore the decimal value. Ignore the decimal value. That means 3.1 is 3. 3.9 also it is 3. Please make a note of these. Very, very important concept. A5 into B5. When both A and B are even, last two digits is 25. When both A and B are odd, it is also 25. One is even, one is odd, or one is odd, one is even. Last two digits is 75. The number before is given by the logic A into B plus A plus B by 2. Examples. Examples. First one, 45 into 65. 45 into 65. Even 5 into even 5. Last two digits is 25. A into B. 4 6 are 24. A plus B by 2. 10 by 2, 5. Answer is 2925. Answer is 2925. Second one, 35 into 85. Even 5 into odd 5. 75. 3 8s are 24. Plus A plus B by 2. 3 plus 8, 11. 11 by 2, 5.5. 5. 2975. 105 into 145. Even 5 into even 5. 25. 10 14s are 140. 24 by 2, 12. Answer is 15225. I hope the logic is clear. 45 into 65. Even 5 into even 5. Last two digits is 25. 4 6 are 24 plus 10 by 2, 5. 3 8s are 24 plus 11 by 2, 5.5. 5. Even 5 into odd 5, 75. 10 14s are 140, 15225. I hope you can do for taking an odd examples also. 35 into 105, 95 into 75, 125 into 145. Three more examples to make the concept absolutely clear to you. 35 into 25. So these 3 is odd, 10 is even. So 75. 10 3s are 30. 13 by 2, 6.5. Answer is 3675. Odd 5 into odd 5, which is 25. 7 9s are 63. 16 by 2, 8. 7125. 12 even and even, it is 25. 12 14s are 168. 26 by 2, 13. Answer is 18125. I hope the idea is clear for all these examples.